What makes a material hazardous? Welcome to the introduction to the Hazardous Materials series. In this series, we'll explore hazardous materials, we'll journey through the safe methods for storage and management of these materials, the types of hazards associated with these materials, and review some of the more common types of hazardous materials we encounter in the fire protection engineering field. The term hazardous materials can refer to a broad range of things, so we will define and discuss what constitutes hazardous material. Before we get into identifying hazardous materials, let's look back at the components that make up a fire tetrahedron. In the fire protection industry, we are concerned with the prevention and protection of fire and its effects. So, we must understand fire and how it behaves. At its basic level, combustion is a chemical process that relies on four elements: heat, oxygen, fuel, and sustained chemical reaction. That's how we get the fire tetrahedron. In our field, we focus on understanding these elements and how we can reduce the hazard of a fire and its effects. The oxygen leg of the tetrahedron is readily available in normally occupied buildings through the air we breathe. In the flammability limits segment later in this series, we will see how the impact of increasing oxygen has on the flammability of a material. And in fact, in this segment, we will see that oxidizers are one of the hazardous materials we classify. It is assumed that there will be a competent ignition source, as we cannot eliminate all ignition source. We can, however, reduce the likelihood of equipment from contributing to ignition source by protecting our electrical equipment and ensuring proper wiring. These are some techniques we'll explore in later segments. When we get to fuel loads in buildings, we often think of these as simply a combustible material, something that burns, perhaps organic, like wood, textiles, paper, or plastics. Or we might consider cooking oil in kitchens, a combustible liquid. When we start to look at the different types of occupancies and how these materials are being stored and used, we can start to see the hazards that are associated with these materials. But what about materials that are stored not in just small quantities, but big, solid piles on racks, on shelves? These materials are being used in a process to create a new drug, food, or medical part. A small pile of wood dust that missed a trash can might not present much of a hazard now. However, if not managed timely, the wood dust can accumulate over time, presenting a larger fire hazard, and then potentially being suspended in air, which can pose a tremendous explosive hazard. Some materials, including gases, liquids, and solids, have properties that we deem hazardous. In addition to the combustible and flammable hazards, we will see that there are other hazards to the accidental exposure or abnormal conditions could significantly threaten the occupants and property. To combat that threat, we impose limits on some building types and apply protection measures to protect the occupants and property. Some of these chemicals can increase a fire hazard, while others can harm occupants in other ways. Some materials, when combining with technology, creates special hazards that, while containing hazardous materials, have specific hazards associated with a type of process or equipment. Energy storage systems or battery energy storage systems are a great example of this. While the battery components contain hazardous materials due to the specific hazards associated with the technology, these require specific and special protection measures. This series will be focused on identifying, understanding, and managing those hazardous materials. Later in this series, we'll explore the protection and prevention systems for these hazards and other special hazards. That begs the question then, what exactly is a hazardous material? In the fire protection engineering field, we look to the codes and standards that we use regularly to get some context. Hazardous materials can relate or refer to many different things, some of which may not be relevant to our field of study. In this series, when we refer to hazardous materials, we refer to the context of chemicals used or stored, not chemicals embedded within building materials, such as asbestos insulation or fire retardant treated wood. These carry health risks and are regulated by other organizations and entities, but are outside of our scope. We are concerned with the what is going on in the building, whether the chemicals are part of a manufacturing process, research, or tabletop experiments, selling goods, cleaning, or even life-saving operations. All of these chemicals need to be evaluated for the various hazard classifications. So, going back to the fire retardant treated wood, if we were to evaluate a facility that manufactured fire retardant treated wood as a final product, we would then be interested in how the chemicals are stored and processed to make this material, ensuring that the hazards associated are managed properly so that we can have these useful products in our everyday lives. The two main documents we look to for the definitions of hazardous materials are NFPA 400, the Hazardous Material Code, and the International Fire Code, or the IFC. As defined by NFPA 400, a hazardous material is a chemical or substance that is classified as a physical hazard material or a health hazard material, whether the chemical or substance is in a usable or waste condition. And similarly, the IBC is defined as those chemicals or substances which are physical hazards or health hazards as defined and classified by this chapter, whether the materials are usable or in waste conditions. These two definitions are essentially identical and further clarify the hazards we are dealing with, physical hazards and health hazards. Physical hazards, as defined by NFPA 400, are a chemical substance classified as an explosive, flammable cryogen, flammable gas, flammable solid, ignitable liquid, which is a flammable or combustible liquid, organic peroxide, oxidizer, oxidizing cryogen, cryophobic, unstable reactive, or water reactive material. And looking at the IFC definition, a physical hazard is a chemical for which there is evidence that it is a combustible liquid, cryogenic fluid, explosive, flammable, solid, liquid, or gas, organic peroxide, solid or liquid, oxidizer, solid or liquid, oxidizing gas, cryophobic, solid, liquid, or gas, unstable reactive material, solid, liquid, or gas, or a water reactive material, solid, liquid. While slightly different phrasing, the core classifications are consistent between these two codes. The physical classifications of hazardous materials include the following. Explosives, these are materials that can undergo rapid decomposition or reaction, producing large volumes of gas and heat, resulting in a damaging pressure wave. TNT, dynamite, and ammunition are some examples of explosive materials. Flammable and combustible liquids, liquids that produce ignitable vapors. Flammable liquids ignite easily at ambient temperatures. They have a flash point less than 100 degrees Fahrenheit, while combustible liquids require higher temperatures to ignite, flash points greater than 100 degrees Fahrenheit. The fuel for a backup generator, the cooking oil in a commercial kitchen, the flavorings in a food manufacturing facility are just a few examples of a type of flammable or combustible liquid that we can see in our world. Flammable solids, solids other than explosives that are readily combustible, may cause fire through friction. Includes materials like metal powders or certain plastics. Note that these are not ordinary combustibles like paper or wood unless they are in specific forms like dust or stored in very high quantities. Flammable gases. Gases are ignitable at temperatures and pressures within a certain range of a gas-air mixture. Propane and propane accessories are a great example of a flammable gas. Oxidizers, which include solid, liquid, and gas, these are materials that readily yield oxygen or other oxidizing substances to promote or enhance combustion of a material. They don't typically burn themselves, but they make other materials burn more intensely or require less energy to burn, creating a larger hazard. Oxygen gas is a prime example, but we also have nitrous oxide, which is common in medical and dental facilities. Organic peroxides. Organic compounds containing peroxide functional groups, the OO, which can be highly unstable and pose both fire and explosion hazards due to their combination of fuel, the organic part, and the oxidizer, the peroxide group. Cryophobic materials. These are materials that can ignite spontaneously in air at or below 130 degrees Fahrenheit without an external ignition source. Unstable reactive materials. Materials other than explosives that in their pure state or as commercially produced can vigorously polymerize, decompose, condense, or become self-reactive under conditions of shock, pressure, or temperature, potentially leading to fire or explosion. Water reactive materials. These are materials that will react with water to release heat or flammable or toxic gases. Contact with water can create severe hazards. Cryogenic fluids, flammable or oxidizing. Refrigerated liquefied gases kept at extremely low temperatures. This is typically below negative 130 Fahrenheit. Hazards include flammability and oxidizing potentials. If applicable, extreme cold weather causing embrittlement or tissue damage, and potential for rapid pressure buildup upon vaporization. Compressed gases, while potentially hazardous due to the pressures regulated separately, unless they also possess one of the other physical hazards. Flammable compressed gases like hydrogen or toxic compressed gases like chlorine. Now we move over to the health hazards. there are health hazards that can cause acute, which are short-term, or chronic, long-term health effects in exposed individuals. The NFPA 400 definition, a health hazard material is a chemical or substance classified as a toxic, highly toxic, or corrosive material in accordance with the definitions set forth in the code. The IFC definition is a classification of a chemical for which there is a statistically significant evidence that acute or chronic health effects are capable of occurring in exposed persons. The term health hazard includes chemicals that are toxic, highly toxic, and corrosive. The health hazard classifications are toxic, highly toxic. Materials that can cause injury or death through ingestion, inhalation, or skin absorption, even in relatively small quantities. Highly toxic materials pose a risk at lower doses than toxic materials. Specific thresholds define these categories within the codes. Corrosive materials are materials that cause visible destruction or irreversible alterations in living tissue like skin or eyes, or significantly corrode steel or aluminum upon contact. Common examples include strong acids like sulfuric acid and bases like sodium hydroxide. Again, these definitions are essentially identical. These classifications will become important later when we look at threshold limits in various buildings. From these definitions, health hazards are limited to corrosive, toxic, and highly toxic materials, while physical hazards are flammable, combustible liquids, gases, flammable solids. Note that the ordinary combustibles are not considered hazardous materials. Explosives, organic peroxides, oxidizers, cryogens, pyrophoric, unstable, and water-reactive materials. A material isn't limited to just a health or physical hazard, though. Many hazardous materials will be classified as more than one type of hazard. This means that we need to comply with all the relevant requirements, ensuring to address all associated hazards with the material. Before leaving this segment and onto the process to use to classify a hazardous material, let's review some common misconceptions that I've heard throughout my career. Common misconception 1, liquids only. I have heard several statements from architects, building owners, and engineers about hazardous materials that they think they don't need addressing. Some of these come up frequently. I don't have any flammable liquids, so I don't need to worry about hazardous materials. We just reviewed the definitions and saw that managing and protecting hazards involve more than just flammable liquids. So while a building may not contain ignitable liquids, it could very well have a bulk oxygen storage. Number 2, small amounts. They are all stored in that room, or we're only using a small amount of such material. We will learn about the limits in various occupancies, and that even when stored under the limits, some considerations or requirements may still apply based on the chemical type. These quantity limitations reduce the higher we are in the building as well. Number 3, basic or common building. The building is just a middle school chemistry lab. Why do I need to know what they use? Chemistry labs still use hazardous chemicals, and in a school environment, they certainly need to be limited to reduce the risk. Students, while learning about chemistry can be fun, still need to learn about these chemicals in a safe environment. Hazardous materials can be found in many occupancies. In large cafeterias, dining halls, restaurants, we find large quantities of cooking oils and other combustibles. They may also have some storage of cleaning supplies in larger quantities. A dentist office that uses nitrous oxide to help a patient's anxiety during cleanings or minor dental work needs to review the storage and use of this gas, as it's an oxidizer. It only takes 2 large cylinders of oxygen to trigger the fire code for a permit from the fire department. Number 4, unknown use of building. I'm not exactly sure what I plan on doing with this building. Can't you just design it? This is the very heart of the building and fire codes. Each type of building has specific uses and functions. While we can plan for certain uses, we cannot design an all-encompassing building. When faced with this response or question, my suggestion is to walk away, as the owner doesn't even know what they want. You could also try to get a better idea of the use. As we just mentioned, many types of the occupancies, we will find hazardous materials, each with its own specific hazards and limitations. Number 5, combustible dust. All we have are these powders, nothing is flammable. Combustible dust can create a serious hazard. Many industrial and manufacturing processes will produce dust, some very fine dusts. Most of the dust is carbon-based, which means it's combustible. The thing about dust is the volume to surface area ratio. A log requires a lot of energy to burn and will burn slowly. But if you take that same log, make sawdust out of it, and disperse it in air, it will require very little energy to ignite and combust very quickly. Having the same amount of fuel as a log but burning much quicker will result in a large pressure wave, and if contained in a building or equipment, it could explode. Later in this series, we'll review combustible dust a bit further, looking at the properties and specific hazards associated with the combustible dust hazard. We defined what hazardous materials are and found out that they are broken into two categories: physical hazards, which involve materials processing chemical or physical properties that could directly contribute to fire, explosion, or other energetic events posing a threat to people or property, while health hazards are materials that can cause acute short-term or chronic long-term health effects in exposed individuals. The physical hazards include the following classifications for hazardous materials: explosives, flammable and combustible liquids, flammable solids, flammable gases, oxidizers, organic peroxides, cryophoric, unstable or reactive materials, water-reactive materials, and cryogenic materials. Health hazards include the following classifications of hazardous materials: corrosive, toxic, and highly toxic. Next, we'll go through the process of classifying a hazardous material. I'm Derek Duvall, and this is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.